Good afternoon. It's my pleasure to be here today. We need to talk about, we have one home planet, that's the Earth. It's changing at an amazing rate. And there is a triangular factor, three things: climate change, people, and wildfires that contribute to this change. If you look at the map there, it shows the changes that have occurred this year alone. In 2023 is the highest temperature on record has occurred this year. And if you look at that map, look at the poles, near the poles, the Antarctic and the Arctic region. It's warming very fast. And the danger that that poses is not something I can explain here, because if the ice sheets melt so rapidly, the sea level rise it will constitute will not be something we'll be happy about. So in the last 5 years, the temperature records have occurred in the last 5 years. The 10 largest temperature records have occurred in the last 10 years. So how does that happen? If we look at this graph on the screen, we'll see the record of temperature rise, how it's been rising so rapidly. And we see some factors that contribute to the temperature rise. One of those is the greenhouse gases that are emitted in the world that contribute, that they have some characteristics, some molecular structure that makes them to trap heat that should escape into space. They trap them, therefore they warm our environment. You will see that the IPCC, the Intergovernmental Panel on Climate Change, has published a report of the emissions of some of these greenhouse gases. And they include carbon dioxide as the chief gas that actually causes this, the warming that happens. How are humans contributing to this? Because when we burn fossil fuel and do other things similar in industry and in transportation and in domestic energy use, we consume energy that releases carbon dioxide and other greenhouse gases that cause the warming. Now, there's another factor that we have not considered very much. If you look at this image you're seeing now, you will see a large fire that happened in Canada this year, in September. And you look at the scale on the bottom left corner there, you will see that the swirl of smoke covers more than 100 miles across. So, and the text there shows that these the rising temperatures have caused fires to continue to increase. There are larger fires now, and they occur more frequently and burn longer. So, so where does fire occur? You'll see the map that you're looking at. I used the fire detection from satellite over 1 year with nothing else there, and just put the points, the red dots, and you can see the map of the world. So every time there are fires in different parts of the world, they occur seasonally, and most of them are actually ignited by people. But in this region, in Northern America and Asia and other places, there are many natural fires. So globally, about 8.8 trillion kilograms of biomass is consumed every year. And that amount of biomass consumed will produce some of the atmospheric constituents you're looking at: the black carbon, carbon dioxide, carbon monoxide, methane, and others, some of which are part of the greenhouse gases that trap heat. Now, you can also notice that carbon dioxide that's emitted, about 13-point-something trillion, is more than the amount of biomass that you burn. Why is that? Because for every activity that occurs, there is an emission factor. Carbon dioxide is the only one that produces more in volume, in mass, than what is consumed. So that's why the emission factor is about 1.6. relative to the others. And we conducted some aircraft surveys in 2008 in Canada, and from there we confirmed that carbon dioxide, carbon monoxide, and methane constitute about 99% of the emissions of carbon in the atmosphere. And from fires alone, they contribute annually about 40% of black carbon. That's a solid particles in the atmosphere that also warm the atmosphere, and about 25% of new emissions. So we are trying to understand the mechanism of the production of these constituents in the atmosphere and how they contribute to what is the global warming. So normally, to determine the amount of emission, traditionally, for any activity, if you find the emission factor, like for instance, if you're talking about cars, if you want to know how much carbon dioxide you emit by burning a certain amount of fuel gas, you can then use that to multiply the amount of fuel gas that you've burned. So that was the method used originally to determine emissions from fires. So then when we looked at fire, what you see here, you see two things. You see the energy, the heat energy, and then you see the smoke. So we developed new methods to characterize the emissions more quickly and more reliably. So we are able to measure the energy from satellite. You see the map there on the lower right corner. And so we decided to develop ways to quantify the emissions of smoke based on the fire radiative power that we measure from space. And so there were two groups that developed that. Our group developed a way to get the emission coefficient that we simply just multiply by the fire radiative power, and we're able to determine the smoke emissions that occur as we measure from satellite. So a few years ago, we conducted a massive airborne and field campaign sponsored by NASA and NOAA. You can see a lot of assets that these agencies deployed in the field for us to go and explore. So if you see, there were so many teams. You will see the image of the aircraft, the massive lab, airborne lab from NASA. And the team there were participating in this airborne campaign and field campaign. And the instrument that I was responsible for was observing the image you're looking at on the bottom left there. You can consider it like looking at windows with filters. Each window shows you different things. So you can see the rightmost one shows you the energy that is being emitted by the fire. So I took this picture there, and when you fly up there, we follow the path of the smoke in the atmosphere. So, sorry. After the observation, we're able to compare what we observed with the instrument on the aircraft with what we observed with the instrument on satellite. The aircraft is about 8 kilometers high. The satellite is about 800 kilometers. So we see that they agree very much. Something else we did was to analyze the data from the aircraft, the energy release data from the aircraft, quantitatively and qualitatively. In the case of quantitative analysis, we're able to quantify the fire radiative power that we use to derive the smoke emissions. On the right side, we're able to look at the different phases of fire, smoldering or flaming, which help us to even get the capability to derive the quantities we need more. So, in summary, the world is changing. Temperature is rising rapidly, and greenhouse gases and carbon dioxide in particular are responsible. But wildfires are contributing significantly to that, and the agencies are actively researching, providing assets to investigate how that's working. And we, the scientists, we are contributing by developing innovative techniques to quantify and study this phenomena. So I would like to acknowledge research grants that I received from different NASA programs and some of the teams that contributed to the work we're doing, and also to acknowledge some of my collaborators over the years. Luke Ellison there is my research associate that helps me to do data analysis, and Yoram Kaufman was my mentor in my younger years. Thank you very much.